Hello everyone, I am Pushkar and this is my project, a self-learning tic-tac-toe agent, which is a Q-learning implementation for continuous improvement in gameplay. So you might be wondering why this project, means why tic-tac-toe. So let me tell you why I chose this classic game. It's simple enough to understand, but it's complex enough to demonstrate real AI learning. Think about it. When you first played tic-tac-toe as a kid, nobody gave you a rule book of strategies. You learned by playing, making mistakes, and gradually figuring out what works. That's exactly what my AI does. It starts by knowing absolutely nothing about the game and learns entirely through trial and error. So before I show you the cool stuff, let me quickly explain reinforcement learning. Imagine training a dog. When it does something good, you give it a treat. When it does something bad, no treat. Over time, the dog learns to repeat actions that leads to treats. My AI works the same way. When it wins a game, it gets a positive reward. When it loses, it gets negative reward. And in draw, it's neutral. The AI remembers which moves led to which outcomes and gradually learns to make better decisions. Now, the secret sauce of my project is something called Q learning. Imagine you are at any position in the game. That's what we call a state. For each empty spot on the board, my AI maintains a Q value. Think of it as a score that tells the AI how good that move is. Initially, all moves have a score of 0 because the AI knows nothing. As the AI play games, it updates these scores. Good moves that lead to wins get higher scores. Bad moves that leads to losses get lower scores. After thousands of games, the AI has built a complete strategy guide in its memory. And here is the Q learning formula you can see, where alpha is the learning rate, where in the formula alpha is the learning rate, gamma is the discount factor, which is the importance of future rewards, and state is the current board configuration. Action is the where to play, cross or O. Now here is what it gets interesting. My AI faces a dilemma. Should it play moves it already knows are good, or should it try new things? This is called the exploration exploitation trade-off. I solved this using something called epsilon rated strategy. At the beginning, epsilon is high, let's say 100%, meaning the AI explores randomly all the time. As it learns, epsilon decreases. By the end of training, it mostly exploits what it learned, but it still occasionally explores. It's like how you might try a new restaurant occasionally, even though you have favorites. Now, let me walk you through how I built this. The project has three main components. First, the game engine built with Pygame for the graphical interface. You can actually click and play against the AI, and it shows the X's and O's on a nice visual board. The second is the learning algorithm. This is the Q learning implementation. It maintains a dictionary of Q values for every possible board state and action. And the third is the training module. I implemented two training modes, one where the AI learns by playing against a random opponent, and another more advanced version where it learns by playing against itself. And let's have a quick demo.